Hello and welcome back. This is our fifth video in this series focused on MATLAB and Octave Programming. We already went over variables, data types and their structures, input and output, mathematical and logical operations. In the last video, video 4, we went over conditional execution, how to control program flow. And in this video, we're going to go over repetition and iteration. So let's get started. With a double percentage sign, we are able to create a cell. So repetition. Iteration. There are some comments. So repeated evaluation of code, or I'm going to say of a block of code, meaning a set of statements, programming statements, is accomplished using for loops and while loops. So in this video, we're going to cover number 1, for loops, number 2, while loops, number 3, I want to say something about vectorisation in MATLAB. Now, for loops, we're going to say that we're going to use them when we have a determined number of repetitions. We know how many repetitions we want to repeat that block of code, evaluate. A while loop, while you can do it and simulate a for loop, typically you're going to use it for an undetermined number of repetitions. And vectorization is trying to avoid loops by using faster vector operations, element by element operations, etc. Now, in these videos, I try to illustrate the syntax and structure of the programming language with very simple examples. Later on, we're going to put all these things together to actually do projects that combine what we have been learning to actually accomplish useful computational tasks, engineering or scientific. So let's do a simple for loop. And let's do something like for k equals 1 to 10, let's go ahead and display something like program, enter the for loop, and perhaps printf, so we practice some of the input-output that we saw in video 2. We're going to say, okay, let's see something like for loop iteration. It's an integer, let's do a new line, and plot the iteration k, and let's stop here. So let's do this. Let's run the selection here. And this is what we see is, okay, the program enter the loop operation, and then we have loop iteration 1, 2, 3, 10 times. Now, this section here, this set of statements, could be any set of code, any set of statements, any code that we will want to repeat, to evaluate, okay, to do a repeated evaluation with a determined number of times. Now, since in programming, a lot of what we are doing is automating tasks, this is very important. There are many times where you have to evaluate something over and over. Okay, so let's add some other statement here. Perhaps let's imagine that we wanted to write this to a file. Maybe that you're doing some computation, and after you're done with the computation, you write that to a file, or you have a ton of files that you need to open, format something, pick up something, and then do something in the programming and then save it. So if you check video 2 on file input output, we could create a file ID and use the function fopen to open a file. Let's say we can do the my results txt file that we were working with, and we can open it with write access. And once we have it open, now we have this ID where we can use the fprintf, which ordinarily sends the output to the screen. We can send it to a file. So let's do this. And say, okay, not to the screen, but to this file. And then when this is done, we can close it. Close in FID. And let's run this again. Incidentally, I'm going to have here CLC so that we clear what we have. So let's run the selection. We went to this screen because we have this printf statement as well as this display statement. And if this worked right, we should see in my results txt the output for iteration with the 10 numbers. So let's pick that up. Here we have it. Now, that will be a write to a file for some results that we have in our program or anything else. The basic structure is the same. Just remember that you can put a block of code inside the for loop to accomplish this repeated task. So that's the for loop. And we're going to use it, like in this case, when we have the number of repetitions. We have an index here. We say for, this gets incremented. In this case, I'm using the colon operator. Let's use a while loop. Now, the while loop ordinarily is going to be used where we say while, and now we have a statement there, a statement with a logical expression that is either going to be true or false. If it is true, it goes to the code. So while that condition is true, we are going to have the statement. And so I'm going to simulate the for loop with a while loop. While k is less or equal to 10, now we're going to, let's do this, same thing. Right here. And I need to initialize k equals to 1, so k is going to be less than 10. This is going to execute, and this, if I left it like that, I would have an infinite loop, right? It's always going to, k is equal to 1, so it's always less than 10. This is going to keep running forever, so I need to have a way of updating this index, k equals, of incrementing k plus 1. That's what we're going to do here. Okay, so let's go ahead and execute this. Instead of saying for loop, I'm going to say for, enter the while loop. While loop. While loop. And what we have see here is that there is an issue in this statement because there is no identifier, no value identifier, and the reason for that is because we close the file, right? So let's open it again. And now we can close it. Actually, I'm going to name this results2. Okay, so we have a results1 and a results2, or results1 and results2. Let's do it. So we executed the for loop 10 times and equivalent while loop 10 times. Now, this typically is not the way you will use the while loop. The while loop typically is going to be used where there is a condition here that it's a logical statement, and you may not know how many times the program is going to be evaluated. Okay. Incidentally, let's check the file. So now we have the for loop iterations and the while loop iterations. Okay. Now let's do a while loop. So while loop. We're going to do a while loop with an unknown number of iterations. Undetermined or unknown. And what I'm going to do is something like this. Let's see, while, let's say something like k1 is not equal to 0. Now I put my code, and I'm going to do the same thing that I have here. And so I'm going to initialize k1 equals to 1, so it's different from 0. That means that the loop is going to execute. I'm going to use another variable here, the k, to count the number of iterations. And now I don't know how many times this is going to be executed, because I'm going to ask the user to enter whether the user wants to do another iteration, like another run of the code. So I'm going to say k1 equals input. Do you want to stop? Enter 0. To stop. Okay, so let's go ahead and run this piece of code. Same situation. We have closed file. So now we are in the loop. Notice what happened here. So we went for the for loop, 10 times. It was the first section of the code. Then we do the while loop 10 times. And now we enter this other while loop. It says, do you want to stop? We are in iteration 0. I'm going to enter 9. Now I'm in iteration 2. Do I want to stop? No. Any number that I enter, the loop is going to continue until I press 0. Okay? So we did 6 iterations. There should be a file. With the results, with the 6 iterations. And this was something that we did not know how many times this block of code was going to be executed, because in this case we were asking the user. Okay. Let's go over the concept of vectorization, as well as for loops with non-integer increments. So let's do something like this. Let's imagine I want to evaluate the function cosine of x for a number of values of x. For x equals 0 to, I'm using the color operator to go pi over 15 all the way to pi. Right? So this expression, I do something like this. That's it. If I say the length of x, effectively this is 16 numbers that I'm going to evaluate. So over here, I'm going to evaluate, I'm going to say y is equal to the cosine of x. And I'm going to plot the result. So let me do this section of the code. So I was calculating the cosine there. So imagine that actually these results, where I am always rewriting this variable y, I wanted to actually create a vector with all the results. Perhaps I could do something like this. And I'm not even going to pre-allocate. I'm going to say my y is equal to an empty vector. And I'm going to say here y is equal to, I'm going to call this like my intermediate step, right? I'm going to call this y1 or y segment. I'm going to say this is y, which originally was 0, and that result, something like this. So what's going to happen in this case? Every time that we execute, I'm incrementing this y. Let's check it out. Notice the first iteration, y segment was 0.9. The first iteration y segment was 1, because it's the cosine of 0, which is 1. And so we have 1 and 1.9. Then we do another, we go over pi over 15. And we go building it. So 3, 4, 5, 6, until we get the 16 numbers. And if I type now y, I have them all, right? We won't construct that. Incidentally, it is faster if you pre-allocate memory. In this case, y had to go increasing the size, right? But we could have said here, for instance, zeros, 1, 16, and this would be a better solution. Notice originally it was 0 throughout, right? Oh, well, in this case, we don't do it like this. In this case, we can already say this is y of we have to have an index in this case. Put an index, k equals 1. I have to say y of 1, and then I increment my index. K equals k plus 1, for instance. Yeah. So let's execute this set of code. We need to y of k, let's put k, and let's execute it. So now what we see here when we go over the iterations is that originally everything was zeros, and then we say first index now is 1, and we go changing them. This is more efficient than the previous code because the memory was allocated. You know how many iterations, and you know the result vector, how it looks in terms of dimensions. You can already reallocate it with, for instance, initiating it all to zeros, as opposed to having to grow the vector with every operation. Now, in this case, vectorization in MATLAB is the general idea of trying to avoid loops, typically for loops, but any loop, for loops, while loops, etc., by using matrix operations, a lot of them element by element operations, that if this was a scalar and MATLAB could only work with scalars, this is the way you would have to do this code. And that's why you have to do it like this in many other programming languages. But in MATLAB, you can simply have your vector x, in this case, right? And you say, well, y is cosine of x. The cosine function operates in each one of the components already. So if we are to look at here, the y versus what we have here, we get the same result, as you can see, but it is much faster. So again, the fact that all MATLAB functions, all built-in MATLAB functions, as well as any function that you will design, should be capable of operating where the input variables to the functions are already vectors or matrices, allows you, as opposed to scalars, allows you to replace many of these for loops and significantly increase the efficiency, meaning the speed of computation. So this is basically the fundamentals of repetition and iteration. Let's go ahead and publish this script. And what we have now is, in the table of contents, of course, what we went over. The variables, input and output, mathematical operations, conditional operation, and repetition. Incidentally, you are going to get an error in this script anytime that you have an input. And so over here, I'm going to make this commented for the purposes of our discussion, and I'm going to actually comment this out. Okay. So let's run it. And there is an issue in line 286. Of course, we didn't comment this part. Now, thank you.